Today I'm going to take a look at a really interesting problem with imaginary numbers. So we have I to the 25th times I to the 31st plus 2I to the 10th over I to the 15th. I want to clean this up, and then we'll have a little discussion about imaginary number I. So when we're just I to the 25th times I to the 31st, this is no different than like x to the 3rd times x to the 5th. What do we do when we multiply by the same base? We add the exponents. So it would be x to the 3 plus 5, and you get x to the 8th. Same exact concept with imaginary numbers. So if I have I to the 25th times I to the 31st, I'm going to do I to the 25 plus 31, and that gives us I to the 56. 25 plus 31 is 56. Okay, then I have plus 2I to the 10 over I to the 15. So what do we do from here? Well, there's obviously quite a few paths that we can take, but I'm going to go the route of let's just factor out I to the 10th. And maybe we don't have to do that. We probably don't, but I'm just, for some reason, just factoring out I to the 10th is sticking out to me as just cleaning up those i's a little bit. So I'm going to factor out I to the 10th, and when that happens, I'm going to have I to the 46, because when I factor out that I to the 10th, what I'm doing is I'm dividing I to the 56th over I to the 10th. And when we're dividing by the same base, same thing with variables like x or y, you subtract the exponent. So it's I to the 56 minus 10, which is I to the 46. So I get I to the 46 plus 2 over I to the 15th. So what do we do now? Well, what I can see now is that I have I to the 10th over I to the 15th. We just had a little discussion about dividing by variable bases, or the same base. We subtract the exponents. In this case, we want to do 15 minus 10, since the bigger exponent's in the denominator. So I'm going to do 15 minus 10, which is 5. Where's that I to the 5th going to go? In the denominator. So I'm going to have I to the 5th in the denominator. So I'll have I to the 46th plus 2 over I to the 5th in the denominator. Where do we go from here? Here is a route. When I have this I, when I'm using I, imaginary numbers, and we have something like I to the 46, and I want to try to rewrite that, and I want to try to see, well, how do I simplify this down? How do I rewrite I to the 46? What I can think about is I to the 4th, and here's why. I to the 2nd times I to the 2nd is I to the 4th. I to the 2nd is negative 1. I to the 2nd is negative 1. Negative 1 times negative 1 is positive 1. So I to the 4th is positive 1. So if I'm able to take this exponent of I to the 46 and I to the 5th and use some rules with exponents and use I to the 4th in some way where I get 1, then I will make this a lot more manageable. Let's take a look. So I to the 46. Let's do this over here. I to the 46. How can I rewrite I to the 46 in some way to have I to the 4th raised to a power, just to clean this up? Well, 4 goes into 46 11 times, because 4 times 11 is 44. So I'll have I to the 4th raised to the 11th, and I just wrote 10 as I was saying 11. I to the 4th raised to the 11th. And what does this need to be multiplied by, though? Because this is going to be I to the 44. And then I have I to the 44, and then I want it to be I to the 46th. So I have to then multiply this by I squared. Because I, getting close to my camera here, I to the 44 plus 2 is equal to I to the 46th. Let me recap that again, because I know that was some fancy footwork there. I use the fact that I know I to the 4th is just 1. So I'm trying to come up with a way to rewrite this with just I to the 4th. Because, just to kind of show you like my thought process here, if I'm taking I to the 4th, this is going to be 1 to the 11th. That's why I want to try to rewrite this using I to the 4th raised to some power, because I to the 4th is 1. 1 to any power is going to be 1. So therefore, this whole entire statement right here is going to be 1. So that's my whole thought process right now, is trying to use I to the 4th in some way. So what I decide is I to the 4th to the 11th is I to the 44, because 4 times 11 is 44, and we're raising a power to a power. Raising a power to a power, you multiply. 4 times 11 is 44. But I'm trying to rewrite I to the 46th. So that's got to be I to the 44 times I to the second. So I to the 4th to the 11th times I to the second. And then that would give us back I to the 46th. So I have I to the 4th to the 11th times I squared plus 2 over I to the 5th. I to the 4th, just talked about that, is just 1. So this is 1 to the 11th times I squared plus 2. And I probably should have rewritten I squared, but that's okay. Let's deal with the bottom also, since I forgot to even rewrite I squared as just -1. Let's just deal with the bottom now. So I to the 5th could just be I to the 4th times I to the 1st, right? Because we're multiplying by the same base. What do we do with the exponents? We're multiplying by the same base. We add. So then that would be I to the 5th. I to the 5th is equal to I to the 4th times I to the 1st. Multiplying by the same base. We don't even have to use like a power to a power rule there, because I could just rewrite this as I to the 4th. And then I know I to the 4th is 1. So now let's rewrite this. 1 to the 11th is 1. So it's 1 times I squared is -1. So it's -1 plus 2 over, and then I to the 4th is 1 times I to the 1st. So we have -1 times -1 is -1 plus 2 over 1 times I is I. -1 plus 2 is 1 over I. And then from here, we're actually not done because we have I in the denominator. So we want to rationalize that. So I'm going to multiply by I now, both top and bottom. 1 times I is I over I squared. What is I squared equal to? We already mentioned that a couple times in this video. I squared is -1, so we have I over -1, which then cleans up to -I. Because I over 1 is I, divided by -1 would just be -I. Let me write that -I. There it is. After all of that work, we get -I as our answer. And this, going back to the beginning real fast, I probably didn't absolutely need to factor out that I to the 10th. I just did that to make the numbers a little bit smaller so I didn't have to deal with I to the 15th, I to the 10th, and I to the 56th. Like, I didn't absolutely need to go ahead and factor that. You probably could have just cleaned that up using that, like the way I just kind of was mentioning. But doesn't hurt to just do it that way. Yeah, so that's the process that I took. The trick here that we want to make sure we know is just this rule of 4. I to the 4th being 1. So then we try to raise 1 to some exponent just so we condense it down as much as possible. And then we're trying to just rewrite some terms since I rewrote this as I to the 44th. So how do I keep this as I to the 46th? Well, I have to multiply by I squared because 44 plus 2 is 46. So I had to offset that change by just changing the visual is all I really did. And we work it down to -I. So hope you enjoyed this problem.